All right. See if you can listen to this song. All right. Lana's here, who's most excellent rock and roll fan, and she's also an accomplished singer. Right? Without looking at that, try to see if you can come up with play a few bars if you know this song. You ready?
Oh, you want?
Yeah, I'm asking you.
Oh, well, it's right there.
Yeah, well, don't look at it.
Well, I know it's Cream.
I know it's Cream, but what's the song?
I don't know. It's too few bars for me. Oh, it's
Badge.
Oh, it's Wow.
Badge. Okay, now, what we want to do here is we have a
kind of like
Tamboro. Is that right? Tamboro.
Yeah,
Tamboro volcano on
Sumbawa.
Sumbawa. I have no idea how to say that, but Sumbawa, we'll go with.
Yeah.
Indonesia. And the ash, now this is amazing, okay? It's 625 meters per second. That's like very fast. You think sound is 330 meters per second-ish, depending on the temperature. So 625, that's like, God, that's almost twice the speed of sound. It's almost Mach 2. Almost Mach 2. What is 625 times 3,600 divided by 1,600?
1,406.30.
1406?
Yep.
Is that okay? Is that enough? We don't have to round it? Okay. So 1406 miles per hour. That's like,
crazy.
Yeah. That's why people in Pompeii, this is a great historical reference. Pompeii was a town on the slopes of Mount Vesuvius. Now, if you know Naples, on the other side of the mountain, on the other side of Mount Vesuvius was Pompeii. And people were trapped. They had no idea how to get away from it. They had no idea. And they thought that, if they ran, they could beat it. But the pyroclastic flow coming out of the volcano, coming down along the volcano, was going so fast, faster than the speed of sound. You couldn't possibly respond to it. Now, Naples is kind of a funny, it's hard to say Naples. I'm getting all kind of turned around, but Naples Harbor, and you got to look at a map. But look at a map, and you'll see where it is relative to Naples. And the pyroclastic flow, what does that mean, pyroclastic flow? That means pyro is fire, and all of the soot and superheated gases and all of the ash and maybe some molten material thrown in there a little bit came racing down the cone of the volcano so fast. This, when we're talking about Mount Tamboro, we're talking about going straight up, right? Yeah. But it's going to go straight up. It's also going to come down the sides. The same thing happened in Montserrat in the Caribbean. Wasn't it Montserrat, the island? It's amazing. Pyroclastic flows are absolutely overwhelming. Well, this is the case. If that's the velocity that the ash is shot up with, and when it reaches its top point, the velocity is going to be 0, right? Yeah, it's going to be 0. It's going to be shot out of the volcano at 625 meters per second, correct?
Yes.
And it's going to decrease its what? Its velocity until it maxes out and then falls back as ash and soot and things like that. And you see pictures of that with Mount St. Helen. When Mount St. Helen erupted, you'd have this kind of like snow. It looked like snow on the television set, but it was actually ash. Mount Pinatubo. You had volcanoes in Mexico, all over the world. It gives this kind of ash color. Matter of fact, when in the late 19th century, when Krakatoa, that was a volcano, it was on the island of Krakatoa, I believe that's correct. That literally changed the climate of the Earth for a few years. Changed the climate of the Earth. So a major volcanic eruption can change the climate of the Earth worldwide. Unbelievable. So anyway, so we're looking for how high it went. What's the distance? Well, I know my final velocity is going to be 0, correct? This is actually my initial velocity, isn't it? That's the initial velocity as it comes out of the volcano,
Okay.
correct? So now, let's rewrite this by this becomes 0. I think I've said this before, that was Dr. Herzog. Loved to make that arrow with the 0. I found that very cool. All right, so that becomes 0 because why? Because v squared, v is 0, 0 squared is just 0. So this becomes 0 equals, what's the initial value? The initial value for this is 625 meters per second, and that's going to be squared, correct?
Yes.
Yes? Now, is it going to be a positive or negative acceleration? Is it going to be a positive or negative acceleration?
Negative.
Yeah, excellent, excellent. Because it's going to decelerate, right?
Yes.
So we're going to say here plus 2 times -10, correct?
Yes.
And then can we move this over a little bit? Let me rewrite that.
Yeah, that's fine.
Say 0 equals 625 squared. I'm going to leave off the unit labels. Is that okay? Makes things neater as long as you're using meters, seconds, kilogram, whatever's needed. Okay, here we're going to use meters per second squared, meters. As long as it's meters and seconds, you're cool. Okay? So this is going to be plus 2, -10, right? -10, and then d. That's what we're solving for, correct?
And -10 comes from it moving down.
Moving, you're throwing it up. In other words, it's decelerating.
10.
If I throw a pencil up in the air, isn't it going to decelerate and then come down?
Yes.
So the acceleration due to gravity, this is what we say in my class. I don't know why they do it the other way in other classes, but if something's accelerating, we say +10. If it's decelerating, we say -10. So it's going to be decelerating because it's going to be going from 625 meters per second to 0.
Yes.
How does it do that? It has to decelerate, correct? Okay, so this is going to be, what's 625 squared?
Oh, it's 390,625.
So can we say this? -365,000,
Yes.
and what's the rest of it?
No. 390,625.
All right, 390,000.
625.
625. So 625 squared is 390,625?
Yes.
And that'll be negative, why? Because I moved it to the other side, right?
Yes.
I subtracted it from both sides. I kind of did 2 steps at once, mental math, okay? And that's going to equal, this is negative, right?
Yes, it is.
So negative 20d. So negative divided by negative is going to be positive. So D equals, so what is 390,625 divided by 20?
A positive 19,531.
19,531.
531.3.
Is that enough? Okay.
Yes.
Meters. Okay. Is that easy? Do you get that?
Yes.
You with me?
I am with you.
Okay. 19,531. Easy?
Yes.
All right. So now let's play around with that number a little bit. Divide that by 1,600. Divide that by 1,600.
12.2.
So 12.2 miles. Okay? 12.2 miles. Multiply that by 5,280. Usually you travel at 30,000 feet, an aircraft, más o menos, you know. 5,280 times 12.2 miles.
Okay. 64,000.
64,000, so it's really twice what an aircraft would travel. Aircrafts travel at approximately 30,000. So that's going to be 64,000 feet.
Yeah, basically.
64,000 feet. Yeah, so it's pretty big, isn't it? So it's a serious, like a thunderhead, really, isn't it? Almost bigger than a thunderhead. You know, like when you're driving. Have you ever flown?
Yes.
And you see, sometimes you're traveling at like 30,000 feet, and you see thunderheads off in the distance that are even taller than what you are. They go on forever.
Yes.
Yeah. So that's the kind of thing we're looking at. We're looking at serious, very serious. So you see how it could get in the jet stream and go all over the world? Yeah. Pretty amazing stuff. Now let's. All right, easy. It's good.
Yeah, actually.
Yeah, pretty good.
Better than
Yeah.
ever.
Yeah. All right, let's do this. Let's say we have to do the other one. It says, excuse me while I read this for a second. It says, on Venus, where the acceleration due to gravity is slightly less than Earth, would this volcanic plume rise higher or not as high as it does on Earth? All right? Would it be higher or lower? What do you think? Would it be higher or lower? I'm going to work over here. I'm going to show you something. Remember this? This was negative. This problem here, right here.
Okay.
We'll say that negative. You know what? I'm going to erase some of this, okay?
Okay.
Can I do that?
Yep.
Okay. Okay. So it's going to be, I said negative V initial squared equals what? Equals equals 2 times negative 10 times what? Times D, right?
Okay.
Correct? So D
All right.
equaled, so D equaled negative V initial squared over 2 times
negative 10.
G, which is negative. Okay, right? Right? So what happens, all right, let's pick a number. Let's pick a number. So it's 2 times negative 10, right?
Yes.
2 times negative 10, right? So what was the value? 625 squared over negative 2 times negative 10. Wasn't that what we did? Right? Yeah? Now, so G is what? What's G?
Is negative 10.
G is negative 10. So on Venus, is G going to be larger or smaller? It says right here. It says on Venus, where the acceleration due to gravity is slightly less,
So
it's smaller. So it'll be smaller, right?
Okay.
So pick a number. 8.
8.
Is that all right?
Okay.
Pick 8?
It's
7.
Yeah.
Yeah? Just less, right?
Yeah.
And whatever you pick, do it less. Okay? So we'll pick one less. We'll make it up. We'll make negative 7 instead of negative 10. Is that all right? be negative 9. Let's say negative 7, is that all right?
Yeah.
All right, good. So here was the value that we came up with, right? So now let's say this is the Venus equivalent, okay? So let's say 625, let's say D equals 625 squared over 2 times negative 7. Is that what you're saying?
Yes.
2 times negative 7. So what is 625 squared divided by 2 times negative 7? Very exciting, very exciting. Here we had 19,531 meters. Here we have, this is going to be Venus, this is going to be Earth, right? What do we got?
Negative 27,000.
No, be positive because this is negative over negative, right?
Yeah, oh, yes, yes.
So what do you got?
Okay, so positive 27,901.
27,901 meters.
Yes.
So who's going to win? Who's going to go higher, Venus or Earth?
Earth. I mean, we are.
Yeah, because this is going to be a positive. This is positive, right?
Yes.
Positive. This is positive. Positive 27,901 meters for Venus.
Yeah.
Because you reduce the denominator, you're going to increase the quotient.
Yeah.
Here is going to be 19,000, so it's significantly larger.
Yes.
I mean, depending on what G actually is, we're just making this up. But the idea is that if it's less, you're decreasing the denominator. You're decreasing the denominator, you increase the quotient.
Yes. Okay.
Do you know what I mean by that? Decrease the denominator, increase the quotient. No, please help him. You get it?
Yes, I get it.
Excellent.
I understand.
All right. Let's turn that off and we'll regroup, okay?